Hi there and welcome to the video. In this video we are going to work through applying the quadratic formula to solve some quadratic equations. A quadratic equation, of course, involves an x squared term. So both of these equations on the screen here are quadratic equations due to the fact they include an x squared term. In order to solve quadratic equations, what we're trying to do is we're trying to find solutions to values of x which would make the quadratic equation equal to 0. Graphically speaking, we're trying to find these 2 points, these 2 intersections of the x-axes. There's a few different ways to solve quadratic equations, one being factorizing, and another of the main ways being quadratic formula. We're going to look at the quadratic formula today. It is usually used when the results are not integers, when the results, the 2 solutions, the 2 roots are not whole numbers. The quadratic formula looks like this. And you can see that it involves 3 letters, A, B, and C. Those letters correspond to coefficients in a quadratic equation. For example, in this quadratic equation, the A is represented by this 2, the B's are represented by this 3, and the C is represented by this -6. We would apply this quadratic formula in order to find our 2 solutions to the quadratic equation. Before we solve a quadratic equation using the quadratic formula, the quadratic expression must be isolated to one side of the equation. So what that means is we need to ensure that the quadratic equation equals to 0. Sometimes the questions will already be equal to 0. Sometimes you'll need to manipulate the algebra just to make sure that the quadratic equation does equal 0. Once we have it in the correct form, you can see that A is the coefficient of x squared. Remember, the word coefficient just means the number in front of. The B is the coefficient of the x, and the C is the integer term, the C value, the constant. So in this example here, A would be 2, B would be +3, C would be -6. Notice that I included that negative when giving a value to C. Once we have the values of A, B, and C, we would then go ahead and substitute them into the quadratic formula. So every time there's an A, B, and C that you can see highlighted here, they would be substituted with the known values. And then we would calculate a solution by including a plus at this stage. And then separately, we would find a second solution by including a minus at this stage. So this plus minus symbol is why we end up with 2 solutions. And if we go back to the shape of the quadratic graph, you can see why most quadratic equations require 2 solutions. Because this U shape, this parabola, usually cuts the x-axis at 2 different points. The reason I say usually is as we could get a scenario where the graph comes down, touches the x-axis at one point, and then goes back up. In that case, we would refer to it as a single root or a repeated root. And when you applied the quadratic formula, you would end up with 2 answers the same. Okay, so let's have a go at an example. If we had the quadratic equation x squared plus 5x minus 14 equaling 0, first thing we're going to do is check that it is equal to 0, check that it is in that standard form that we would like, and this question already is. Then we just need to highlight A, B, and C. The coefficient of x squared, when there's nothing there, of course we assume it is 1. So a would be 1 in this case. B would be 5, the coefficient of x, and our constant term is negative 14. So I'm going to substitute 1, 5, and negative 14 into the quadratic formula to get our two solutions. Here is the quadratic formula. I've wrote it out. Now I'm going to go ahead and do the substitution. So you can see every time there was a b, I've substituted in 5. Every time there was an a, I've substituted in 1. And every time there was a c, I've substituted in negative 14. Just going to go ahead and tidy this up a little bit. Remember, the calculator will help you with that. So what I did is I simplified the values under the square root sign. This part of the quadratic equation is known as the discriminant. And in this case, the discriminant would be 81. The fact that it is positive is important. We'll talk about that later on in the video. So now we're left with minus 5 plus or minus root 81 over 2. So to get our two solutions, we take this calculation with a plus to get one of the solutions. And then separately, we take this calculation with a minus to get the second solution. So once I take that calculation with a plus, remembering that the square root of 81 is of course 9, that gives me my first answer of 2. And then I take the solution with a minus, and that gives me my second solution of minus 7. So notice the differences there. We've got a plus over here, and for the second solution, we've got a minus. So the two solutions to this quadratic equation are x equaling 2 or x equaling minus 7. Okay, so let's have a look through a couple more examples. Just remember that in an exam, if you're ever asked to give an answer correct to 1 or 2 decimal places when asked to solve a quadratic equation, that's a big hint that you need to be using the quadratic formula. The quadratic formula is given to you on the first page of the GCSE paper, so it is contained within the formula booklet. But of course, that's no help unless you understand how and when to apply the quadratic formula. So we know we need our quadratic equation in this form, and then this is the formula we apply, once with a plus to get our first solution, once with a minus to get our second solution. We're asked to solve x squared plus 7x plus 5 equals 0. Give your answers correct to 2 decimal places. The fact that it's asking for decimal places, not integers, suggests that it can't be factorized, and therefore we have to use the quadratic formula. We're going to identify a, b, and c. Coefficient of x squared, coefficient of x, and the constant. A, b, and c. 1, 7, and 5 in this question. We're going to substitute those values into the quadratic formula. And we're going to simplify the discriminant part of the quadratic formula. Of course, you can just put this whole process into the calculator without the simplifying part. Now we're going to calculate both answers. So we're going to calculate this with a plus, and then we're also going to calculate that with a minus, remembering to round both solutions to 2 decimal places as the question asked. One more example from me before I give you a few questions to do. This time we're asked to solve 2x squared minus 8x minus 3 equaling 0. It's already in the correct form, and I want my answers to 2 decimal places. We're going to identify a, b, and c. A is 2, b is negative 8, and c is negative 3. substitute my values into the quadratic formula, simplify if appropriate or if you need to. Then we're going to get our first value and we're going to get our second value, and of course we need to round them appropriately as the question has asked. Okay, so now it's your turn to have a go at a few questions. 3 questions on the screen. For each question, I'd like you to give your answers correct to 2 decimal places, and you must show your working. Could you pause the video at this point and have a go at all 3 questions? Welcome back to the video. We'll just talk through each of these questions. So in question 1, we've identified A, B, and C. We've substituted 1, 4, and 2 into the quadratic formula. We've simplified the discriminant part of the quadratic formula to give us 8. Of course, we could just substitute this. We could just put this bit into our calculator. Then we get our 2 values, both of which are rounded, our 2 solutions for x. Question 2, we take a very similar approach and we end up with our 2 rounded solutions of x. For number 3, we highlight A, B, and C, substitute into the quadratic formula, and we round our 2 solutions of x. Very well done if you are able to confidently show your full working out on those 3 questions. 3 more for you to have a go at. Exactly the same. Could you pause the video at this point? Could you show me your full working out and full understanding to get your 2 solutions for each quadratic equation? Okay, welcome back to the video. Okay, welcome back to the video. So you can see the process for 4. I've identified A, B, and C. I've substituted and I've rounded my solutions. For question 5, same method, same process. And for question 6, same method, same process again. Very well done if you were able to answer all 3 questions correctly again. Okay, so here is a task for you to have a go at. What I've placed on the screen is 8 IGCSE exam questions. They all require you to apply the quadratic formula. You will see in most questions, they're asking you to round either to significant figures or to decimal places. So that's telling you that you're not dealing with integers, you're not dealing with whole numbers. It is also a good clue in the exam that you're being asked to apply the quadratic formula. For each of these questions, I'd like you to approach the question with the same method. I would like you to highlight A, B, and C. I would like you to show me the substitution that you've carried out, and I would like you to show me how that has led you to your 2 different solutions, rounding those solutions to what the question asks for. Okay, so at this point in the video, could you pause the video and work through all 8 questions showing your full working out? Okay, welcome back to the video. I'm just going to go ahead and show you my full worked solutions. So your answers should look something like this. So you can see for each question, I've highlighted or found A, B, and C, the values of A, B, and C. I've then used those values to substitute into the quadratic formula. Then I've calculated, with the help of my calculator, 2 different solutions, one using a plus and one using a minus, and then I've rounded the answers to whatever the question has asked. So you can see how I've presented my answers, and you can see how I would go ahead and pick up full marks in an exam. Very well done if you were able to find all 8 pairs of solutions. And here we have one more task for you to have a go at. 8 questions on the screen. For each of the questions, I would like you to solve the quadratic equation by applying the quadratic formula. For each question, just like we've done throughout the video, you should be highlighting the values of A, B, and C and using those values in order to find your 2 solutions to the quadratic equation. If you could pause the video at this point, work through all 8 questions, showing your full working out and your full understanding of this topic. Could you pause the video now, please? Okay, welcome back to the video. Here are my worked solutions. So you can see that I've highlighted both of my values of x, both of my solutions, both of my roots to the quadratic equation in each question. If you could spend a little bit of time just marking up your work, ensuring you've rounded your answers to the correct accuracy as asked in the question. And if you were able to get all 8 questions right, that is brilliant. You've shown a very good understanding of applying the quadratic formula. Just before we finish up the video and the topic of quadratic formula, I would like to talk about this situation. Let's just have a think of the question. Why can't the quadratic formula solve x squared plus 2x plus 3 equaling 0? Why would we not be able to apply the quadratic formula in this case? Let's have a think about that. Here's our quadratic formula, and we've substituted in our values of a equaling 1, b equaling 2, and c equaling 3. Let's focus on the discriminant area of the quadratic formula as we work through this process. When we simplify, you will see that the number under the root sign, the discriminant, is actually a -8. And of course, we cannot take the square root of a negative number. So therefore, the solutions to this do not exist. This quadratic equation does not have any solutions. And why is that? Let's think about the graph. That parabola, that U-shaped graph that we always associate with quadratic equations. If it can never be 0, the graph would look something like this. So the parabola never intersects the x-axis. We still have some intersection at the y-axis on this example, but there is no intersection of the x-axis, which is why when this equals 0, there is no solutions to this via the quadratic formula. And if we were to put that into the calculator would give us an error message.